Good evening. Students. How are you doing today? Hello, guys. How are you doing today? What is somebody? All right, guys, trying this another time. Good afternoon, good evening. How are you doing today? Hello, somebody. All right, I'm trying this another time. Good afternoon, everyone.
Good evening.
Hi, mister. I've been saying hold it for the longest while.
Sir, I didn't hear you.
Okay, hold it do.
Fine, sir.
Good
How are
job.
you?
Oh, I am a very good. What must go on?
So you sure you're okay?
Yeah, man, I'm good, man. Thanks for asking, hon. I'm better this week. Last week I was a wreck. I'm better this week. I mean, I still have it on my mind, but not as it was so fresh last week that I couldn't get over it. But I'm doing much better now. So Ottilie asked me to send off something in the group, but I also asked her to send me the question again so that I can redo it, because for the life of me, I don't know where it is. I cannot tell you that I can put hands on it. And I know, I'm almost sure that I was working with the document on screen. But anyhow, as soon as that is sent, I can definitely assist you further. All right, there's another question now though. We were on, can you remind me? McLaren's expansion, that's what we started, right?
So I'm not sure what it was called, but I know how it looks.
Tell me how it looks.
Sir.
Just tell me.
Wait,
Is it the one that we have to put 0 into the original stuff and then we have to differentiate several times?
Yes, sir. We don't have, yeah.
That's McLaren's.
So I have the whole heap plus this plus that.
For differentiation, yeah.
Okay.
So you need to know the areas, because I know you know how to do them. You need to know what the areas are like. So I spent a few minutes on it today. As a recap. What's your Zoom changing something?
Yes, sir.
You see that too?
Yeah.
Yeah, out of that already, so I'm just going to prefer.
Sir, me used to the all.
They have changed their stuff on us. Z for Zaro. Anybody used to remember watching Zaro? Only too young for Zaro. All right, so as a recap, the Maclaurin's theorem for approximating functions with the infinite series, that's what we use. F of x is going to be equal to f of 0. So we have to find 0 of the function. We have to find 0 of the function. We have to find 0 of the function. Now, when we find 0 of the function, then we have to differentiate it. When we differentiate it and get our first derivative, then we're finding the 0 of that derivative times x. The third term, we're going to differentiate it a second time to find the second derivative, and we're finding the 0 of that second derivative. We're finding the 0 of that second derivative. Having found the 0 of the second derivative, we're going to divide that answer by 2 factorial and times it by x squared. Similarly, we're going to find the third derivative. If the answer to go above 3, we're going to find the third derivative. When we would have found the third derivative, we're going to find the 0 of the third derivative divided by 3 factorial. Dividing by 3 factorial, we're going to multiply by x cubed. And if we were asked to go up to the fourth, we would find the fourth derivative, find the 0 of the fourth derivative, divided by 4 factorial times x to the fourth. And if they ask you to go to the fifth one, you're going to find the fifth derivative. You're finding the 0 of the fifth derivative, divided by 5 factorial times x to the fifth. So I say this to say to you, it's not difficult. What is not difficult is how the Maclaurin's theorem is set out. Because the first term, you're going to find f of 0. The second term, you're finding f dash of 0 over 1 factorial times x. Then f double dash, the point is, this is 2 second derivative over 2 factorial times x squared. Third derivative, so you have a 3 here, you have a 3 here, you have a 3 here. You have an n here, you have an n here, you have an n here. So you can't go wrong. So if I ask you to find the 10th one, it's going to be the 10th derivative. You find the 0 of the 10th derivative over 10 factorial times x to the 10. Fair enough?
Yes, sir.
All right. I want the rest of you to also chime in and participate. Remember, we have a plan. Plan is within the pass this course in this semester. And the review of the factorial, we found that on our calculators. It's the one with the exclamation. It's the one with the exclamation. So wherever you see the exclamation sign on the calculator, normally written to the top left-hand corner. If you look for that signal and you press 5 and then press that symbol, it should give you 120. 5 factorial is 120. How do we do it otherwise? Whenever you see the factorial, it means 5 times 4 times 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right? And then I think we looked at that example. But before I recap that example, are the rest of you hearing me? Are the rest of you around your computer? Are the rest of you ready for class? I'm only hearing Nesta. Hello, somebody? You know, Nesta is there. I want you to the rest of you are there.
Sir?
Yes, Nesta, what's up?
Oh, sir, I think you're mute or something.
I don't know. I'm here. I was waiting for the others to come back to class. So I was going to give you guys, maybe 5 minutes and then I come back. All right?
Okay.
Mhm.
Sir, I think you can continue. Mr. Chan.
All right, you guys are ready to go now? Or we stay?
Yes, sir.
All right, good job, Mr. Thanks for being on alert. Automation, Daniel. Mhm.
Sir, call.
I've been calling Daniel. You're not there.
I'm here, sir.
No, my drop a statement because I've been calling and I give time up because nobody not so Nesta alone that was responding to me.
I'm here now, sir.
Awfully.
Yes, sir. Sir, so you met me last night and got caught up.
Oh, but is it? I was
Yeah.
gonna ask you now because for the life of me, I just can't find the document, and so I was hoping that you'd have sent it off to me so I could have done the solution to resend the document. I don't know where it is. I know I had projected the stuff and I know I was working on it, but it was like I closed up the computer and forgive me. When you send this stuff, I take my time and work it and type it and send it off to you guys here.
Okay.
Forgive me.
No, Chanel came back, but you was asking. Yes, sir, I think me get me good within the first topic. Good with it.
You don't get this one.
Topic, yeah, I'm not get it that.
All right, so that's
Yeah,
why
but I think because me I practice the first one more, me not grasp this so well.
All right, so that's why I am going through this one again. So that's what I'm doing. I'm actually going through the solution, but when I was calling upon people, they weren't responding to me, so that's why I took a break. So my aim is to go through this once more, so at least we can. So this example that I'm looking at, I think it's a very example we went through last class. Is that true, Nestor? Is this the same example or is that a different one I looked at?
Repeat, sir.
Is this the example that I did in class last
Yes,
time?
sir.
All right, good. So I want an opportunity to just go through it again so I can give you something to do. I don't like Shayna's Wi-Fi because she is in and out, and I'm a little concerned that she is losing out. All right, so so what I was explaining is the whole business of the McLaren series. Whole business of the McLaren series. And in McLaren's, we have several things that we need to do. Thing number one, we have to learn how to differentiate. If you don't know how to differentiate, it's going to pose a problem. I'm expecting for the McLaren's that we get a full question from McLaren's. McLaren's is one of those topics that must come. So we did one already, Newton-Raphson, that we know must come. We did another one from McLaren's. And between these two questions, it's a minimum of 15 points. Because Newton-Raphson alone can come for 10 points. McLaren's can come for 10 points also. Right? So between these two questions, it's about 15 points. 15 points, and there's a question that is going to come for about 20 marks. So that's a 35 points. So there's no way you can fail the course. Nobody can fail the course. So I want all hands on deck. And I want you to be able to follow what is happening. Hopefully, I'm going to ask to drop the link for the WhatsApp group in the chat, please, so that others can join. Thanks. All right, so let's go ahead now. So let me stop share and reshare again, because this line that is inside of the screen says that it wants to stay with me and I don't want it. All right, so let's go. All right. So let's go. So we're given a question. The question says, let f of x. Let's get that. Something. It says use Maclaurin's theorem to expand 1 over x plus 1 up to and including the term in x to the fifth. This asking us to expand using Maclaurin series. I've shown you how to remember Maclaurin series already. I've shown you how to remember Maclaurin series. All right. So we don't need to use it to do that sort of expansion. To do that sort of expansion. So let's go. You're given a question. You're given a question. The first thing you're going to do is to find the zero of the function because Maclaurin is asking us to find f of 0. Here, to find f of 0. So anywhere in the function I see x, I'm putting 0 in order for me to find f of 0. So it becomes f of 0 is 1, 0 plus 1. And then I'm going to evaluate. And the value is 1. So 1 over 1 is 1. And that's why I get this one right here. Tell me that you see what is happening right there, please.
Yes, sir.
All right.
Sorry.
So I just ask a question. A very important question that I need to ask. Do you want to estimate?
What did you ask, sir? Sir, we're not here yet.
I'm asking, do you want us to have class tonight?
Yes, sir. Yes, sir. Ready for class.
Yeah, man. So talk to me now, man. It don't feel nice when I talk to myself.
All right, sir. No problem.
Yeah, man. It don't feel nice when I talk to myself. So I want you to answer me, man. Me get the energy. Because you soon want to start sleep. And I'm going to say this one more time. And I want you guys to follow what I'm saying. There is a trend of persons not participating in class, and I mark those papers. I'm seeing those persons who are not participating in class are the ones failing because we log on, but have 1,000,001 things to do. We're fooling ourselves that we're in class, but we're really not in class. Me no so tired. Gonna go work. At the end of the week, me know that I'm tired. I'm very tired myself, but we have to go do it. I've committed myself to the group. You know, the guys to commit yourselves to me. I've committed myself to the group, not to commit myself to me. And I'm committing myself to me.
Okay, sir.
All right. So this is what is happening. I now need to find the first derivative of the function. I now need to find the first derivative of the function. I now need to find the first derivative of the function. But it's a quotient. How do you know it's a quotient, sir? Because it has a denominator. It also has a numerator. Numerator up top, denominator down, D for denominator, D for down, denominator at the bottom. All right. So you have a numerator, you have a denominator. You have a numerator, you have a denominator. All right. So you have to be very careful. Hold on a minute, please. Hold on a minute, please.
Natalie,
You know?
you know the asymptotes topic, you know, to do the vertical asymptotes.
Not fully, no, remember. It's,
I don't go through that yet.
you should not do it yet. Sorry, not do it yet. Sorry.
Oh,
Chanel. Just the second topic, sorry.
I don't know what the second. This is the second topic?
Yeah.
McLaren, yeah.
Oh,
Can I go down, Shin?
yeah, man, sir. Yeah, some
Oh. Oh. All right, now, so continuing. So I'm having my first derivative. Now, allow me to remind you how to differentiate. Allow me to remind you how to differentiate. Actually, use one ear and listen to me, please, but use the other ear and send Shani a thing for coming to the class, please. I know she may have be having Wi-Fi challenges because she's in and out.
No problem.
Thank you, hon. All right. So I'm differentiating. Differentiating a quotient is a denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. We all know that because we all have calculus 1. It's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square.
numerator.
So it's a denominator, watch me. Don't write it, just look at this. It's a denominator. See here? Sorry, x plus 1. There's a delay in my computer, so forgive me. X plus 1 is a denominator. It's a denominator, see right here, so times the differentiation of the numerator. When I differentiate a constant, I get 0. So see here, times 0. Minus the numerator, minus 1. See it right here, so times the differentiation of the denominator. When I differentiate x plus 1, I'm going to get 1. See it here, so times 1. All over the denominator squares. This is this. So my differentiation ends right here. My differentiation ends right here. What is now left? What is now left is for me to fix up. This 0 times anything is 0. So all of this term will go. And I'll only be left with negative 1 times 1. And negative 1 times 1 is negative 1. See it right here, sir? And I'm going to have the x plus 1 all squares because that is not going to be touched. As I told you in calculus 1, we never try to do anything more with the denominator. So that is going to remain as x plus 1 all square. All right. Next, we are going to find f dash of 0. Anywhere in the function I see x, I'm putting 0. Anywhere in the function I see x, I'm putting 0. Says f dash of 0, see to yourself, over negative 1 times 0 plus 1 is 1, and 1 squared is 1. Negative 1 divided by 1 is negative 1. Negative 1. One of the things I'm going to do with you in class is, since I have copies of them, I'm going to scan some of those exam papers that students would have done. You won't see the name, so you won't know who it is. Unless you can identify the handwriting. But I'm gonna scan. I may not even know them because it's old time papers. I'm gonna scan. I'm gonna scan some papers and show you the mistakes that students are making in class. I'm going to show you the errors that students are making in class. We need not make those mistakes, and we don't have to make those mistakes. We don't have to make those mistakes. I promise you, we don't. All we need to do is just focus on what is being done now, what is being taught, memorize it. Otterly says, sir, Newton-Raphson is not a problem because I practice it. And no, Nesta was practicing it that also. Nesta's problem is that she not remember the names of the topics. So she know what to do, but not remember the names. Right? So what I want you to do is just to put pen to paper and start working. If you do that, I promise you, you can't fail. All right, so let's go. Start from dash of 0. All right. Then the next thing we're going to do all of this. We now need to find f double dash. F double dash is representing the second derivative. F double dash is representing the second derivative. So I need to differentiate the function one more time. I need to differentiate the function once more. I need to differentiate the function once more. Now, when I differentiate the function once more, I'm going to go again and say the denominator. The denominator, see, x plus 1 all squared, see to yourself, the denominator. Times the differentiation of the numerator. When I differentiate -1, I'm going to get 0. See here? So why? Because when I differentiate a constant, I get 0. Minus the numerator, see here is minus the numerator. The numerator is negative, so I'm going to end up with 2 negative signs right here. Times the differentiation of the denominator. Now I need to differentiate the denominator. How do I differentiate the denominator? It's going to be, this is known as the power rule. So this 2 is going to come in front of here. See the 2 right here, so. Then I'm going to reduce this power by 1. See here, so there's an imaginary 1 here. And then I'm going to differentiate what is on the inside of the parentheses. So I have x plus 1. When I differentiate x plus 1, I'm going to have 1. So I have that 1 right here. All over the denominator squared. So I have x plus 1 all square. That gives me x plus 1 to the 4th. X plus 1 all square is going to give me x plus 1 to the 4th. Then what I'm saying here is that all of this goes to 0, because 0 times anything is 0. And then what I'm going to have now is that this x plus 1 is going to cancel into one of these and leave a remainder 3. So my denominator now have x plus 1 to the 3rd power. I will now have x plus 1 to the 3rd power. See here, so x plus 1 to the 3rd power. Then I need to work out the numerator. All of this goes, so I'm just going to have this 2 times 1. 2 times 1 is 2, right here.
How the denominator become x plus 1 to the 4th power?
Because it's x plus 1 square. Remember, it's all over the denominator squared. So we already have x plus 1 squared. So when the square it again, we can get to the 4th power, right? You see, Shin?
Oh boy. Yes, sir.
Make sure you know. All right? Okay, let's go now. So what is going to happen now is anywhere in this function I see x, I'm putting 0. 0 plus 1 is 1, and 1 is 1. So I'm going to have 2 over 1. Right here?
Yeah.
Right here?
Yes, sir.
All right, watch me again. Watch me again. All of you, watch me.
Numerator times the differential of the
Denominator. So what? That's where I reach. No, don't go no further. That's where I reach. I'm differentiating the denominator. So watch me. The denominator is a power. Let me go up here and look at this power rule. The denominator is a power. So this 2 goes in front. Then I'm going to write back this power and reduce the power by 1. See here? So I have 2 minus 1. And then I'll have to differentiate what is inside of the parentheses. The differential of 1 is 0 because they're constant. And when I differentiate x, which is the same thing as 1x, I'm going to get this 1. That one up here. And that's why I got that 1 times 1. And then when I fix it up now, this 2 is the same as this 2 right here. And 2 minus 1 is 1. And I don't have to write 1x. I can just simply write x, which is here. And this times 1 is this 1 here. And then 1 times 2 is this 2. And I'm left with x plus 1 to the first. I don't have to write to the first. I can just write x plus 1. Follow me?
Right. Yes, sir.
All right. And then now, come on, guys, it's still up. And then now, what I'm going to be doing is to differentiate the function a third time. I'm differentiating the function a third time. So remember, every time this topic is on the application of differentiation. So I have to be differentiating over and over and over and over. I have to be differentiating over and over and over and over and over and over again. Very important. Very, very important. So what is now happening is I'm going to differentiate this one. So it's the denominator, x plus 1 to the third. See it right here, so I have to put it in blue. X plus 1 to the third. Times the differentiation of the numerator. And I differentiate 2 is a constant, so I'm going to get 0. Minus the numerator, minus 2, see the 2 here, minus 2, times the differentiation of the denominator. So I'm differentiating the denominator. The denominator again is a power. So this 3 is going to come in front of here. Then I'm going to have the x plus 1 to the second power. I'm reducing the power by 1. Then I'm going to differentiate what is on the inside of the parentheses. When I differentiate what is on the inside of the parentheses, I'm going to get 1. And then this is now over x plus 1 to the third. When I square that, I'm going to get x plus 1 to the 6th. See it right here, so. Then all of this goes to 0. And negative 2 times 3 is negative 6. And negative 6 times 1 is negative 6. This piece in blue over this side is going to cancel out into 6 of these. So it's going to be 4. So I'm just going to have negative 6 over x plus 1 to the 4th. But I can tell you that to see it.
So when you multiply power, you add, right?
Yeah. Yeah.
So 5 is supposed to get to the denominator for the third derivative.
No, because I'm going to have x plus 1 to the third times x plus 1 to the third. That's what the square is. So 3 plus 3 equals?
Oh, okay.
1.
Well, that makes me up, you know.
No, you're correct. You said the correct thing, but you said the correct rule, but did the incorrect stuff. So when you're multiplying and the bases are the same, you add the powers. So x plus 1 to the third power times x plus 1 to the third power. Because the bases are the same, x plus 1, you're going to add the powers. 3 plus 3 to give you 6.
Okay.
Mm-hmm. And then you're going to substitute 0 into the function, and with the function is the x, you put 0. So I'm going to have 0 and 1. So I'm going to have negative.
Yeah, break up.
A to the n raised to the n more is equal to the n. So x plus 1 to the 6. Hold on. You must take my internet is unstable. Hold on one. Am I coming across a little better now? No?
Yes, sir.
Oh, thanks for the notification. So a to the m raised to the nth power is going to be a to the m times n. So watch me. So if this is x plus 1 to the third, and I'm squaring it, it says that I'm supposed to multiply it to the powers. So this 3 times this 2 is going to give me 6. That's why I end up giving a 6. I'm differentiating this piece one more time. Watch me. Don't blink. The denominator, x plus 1 to the 4th, see here? X plus 1 to the 4th, times the differentiation of the numerator, and I differentiate a constant, I get 0. So it's times 0. Minus the numerator, so I put minus, the numerator is negative 6. So it's minus at the numerator, which is negative 6, times the differentiation of the denominator. Now I need to differentiate x plus 1 to the 4th. When I differentiate x plus 1 to the 4th, this is going to be a 4 coming from, see it right here, so x plus 1, and I'm reducing this by 1, so I'm going to have x plus 1 to the third, and then I'm going to differentiate what is on the inside. Differential of positive 1 is 0 because they're constant. I'm going to differentiate x, I'm going to get 1, so that's why I have this plus 1, this times 1 here. And then, similarly to the others that we've been doing, this is x plus 1 to the 4th all squared. This rule tells me that when I have a base raised to a power, which in turn is raised to another power, I multiply both powers. So I'm going to multiply the 4 by the 2, 4 2 is 8, so I get 8 right here. So see that? Talk to me.
How much it take to go to again? 5.
Yes, sir. Yeah, bye. X to the 5th. Are you understanding so far, guys? Talk to me now.
Zero plus 6. 6 times 4. 24.
No, you're looking over the stuff. Make sure that you're actively looking over the stuff. Not rushing you, because when I finish my clearance today, I'm not going back to it. Those of you who have not joined the clinical class, the WhatsApp group, please do click on the link right here, so these and plans. Very important.
Sir, can you scroll down real quick? Is there a fifth derivative?
There is a 50-50, but I don't want to get on there, my love. What I want to do is I just want to stay here 1 second. I know you may be here, but I just want to stay here 1 more second before I go down.
Okay.
My man.
So 6.
Waiting on me to tell me that I can go. Look at it and understand. Yes, sir. I see it now, sir. You can move.
Yes, sir. I see it now, sir. You can do it.
All right. So now, when I would have gone through this, let us go through this differentiation again. The denominator, which is x plus 1 to the 4th, times the differentiation of the numerator. Differentiating the numerator is a constant. So when I differentiate the constant, I'm going to get 0. So I'm going to have a 0 right here. Minus numerator says minus the numerator, which is a -6 right here, times the differentiation of the denominator. So I now need to differentiate x plus 1 to the 4th. So I'm going to have 4 times x plus 1 to the 3rd times the differentiation of the inside. And I differentiate x plus 1, I'm going to get times 1. And all of that is over the denominator squared. So x plus 1 to the 4th, all square, remember, or multiply the 4 by the 2. So we're going to get 8. Added multiply the 4 by the 2. And then now we're going to have all of this going to 0. -1 times -6 is +6. And 6 times 4 is 24. And 24 times 1 is +24. So I have that 24 up here. And this x plus 1 to the 3rd, we'll take out 3 of this and just leave x plus 1 to the 5th. Right here, so. And then I'm going to substitute 0 into the function here. Substituting 0 into the function. And when I put in 0 into the function, I'm going to have 0 plus 1 is 1. 1 to the 5th is 1. So 24 over 1 is going to be 24. 24. My assistant is calling. You take a half a second. Here, indeed, it was school business. All right. So yes, Nestor. So this is the 5th one now, the 5th derivative. I'm differentiating here. So it's the denominator, x plus 1 to the 5th. This times the differentiation of the numerator. The numerator is 24, a constant. Whenever I differentiate a constant, I get 0. So I'm going to have 0 right here. Minus numerator, minus the numerator is 24, positive 24, so it's minus 24. As opposed to this one where I have minus minus. The numerator was -6. All right. So minus the numerator, which is minus 24, times the differentiation of the denominator. So I'm differentiating the denominator. So it's going to be 5 in front times x plus 1 to the 4th. See it right here, so. Times the differentiation of the inside. When I differentiate x plus 1, I'm just going to get 1. All over the denominator square. When I have x plus 1 to the 5th, all square, it gives me x plus 1 to the 10. Gives me x plus 1 to the 10. Then, remember, we're always trying to find the zero of a function. So all of this goes to 0. 24 times, negative 24 times 5 is going to be negative 120. And negative 120 times 1 is still negative 120.
I notice a trend whenever you multiply the power, the denominator power by the numerator, I get that's the next the next answer for the next step.
And this trend works only with certain functions. So certain functions, so once you start doing it, you will see the trend come up. So if you are very diligent, you will see the trend. So if you make a mistake, your brain knows that the one and now follow the trend. Very good observation, and I'm happy for that. Because when I was doing it, when I was going to school, I was very meticulous with my calculation. I was a very slow worker because I don't want to make a mistake. Come on.
So
No. I used to catch the stuff, you know. But when I'm doing tests, I used to work the questions very slowly because I don't want to make any mistake. Yeah, man. So if you give me a test, for half an hour and give me 3 questions, I will do maybe 2.5 questions because time always run out for me.
Me too.
But guess what happened? Instead of 2 questions, the 2.5 questions I'm doing, I will get full marks again because I now make a mistake in it. Right? So my teacher used to rough me up and said, you need to put some pep into the stuff, man. So now I start, to increase my speed. Try to understand the stuff so you can increase your speed because one of the things that you're doing is working against time. So one of the other things is that some topics must come on the exam. If the topics that must come, know them inside out. Know them inside out. Now wait upon nobody to tell you nothing. Know them inside out. So anyway, you angle triangle it, you must get it. You must get it. Because sometimes them twist you up. What is that? What am I trying to do? Angle triangle that, boom, full marks. Say cut through. Yeah. So it is what it is. So you have to, but remember now, if you don't practice what it is that you're doing, I'm not ask you. You're not gonna get it. You're not gonna get it.
Speaking of which, you start add people to Educasoft yet?
Yeah, man. So that's why I asked you to put your join the WhatsApp group because my next step now is to say such and such and such. Drop your email. We need to add it to the WhatsApp. To the Educasoft. So this one you go to Educasoft.
Okay.
All right. So remember, I'm taking my time to go through this because part of the reason, again, the learning process is not me always coming to class and talking. It's not a lecture. I'm presenting the information, but you guys will know how to put pen to paper and try to something on your own. So I'm going through this slowly because the next step is for you to try it on your own. All right. The next step is for you to try it on your own. So I'm depending on you to do that. Let's go. So I'm gonna end up with negative 120 over x plus 1 to the 6. When x is 0, 0 plus 1 is 1, 1 to the 6 is 1. Negative 120 divided by 1 is negative 120. All right, I'm gonna say something before I even move on to the last part. I'm gonna say something. I'm not gonna tell anybody. Okay, sorry, let me start again. One of the things that I like about my class is that I try to create an environment where students are free to talk. Free to talk, all I ask is that to be respectful. Just remember that I'm a teacher and just to be respectful. But I always say to you, talk your mind. If you're frustrated, say, sir, hold up. I'm frustrated. Talk your mind. I love when people express themselves because people have feelings, and just like how I want to express myself when I'm hurting, I'm not going to say to somebody you can't express yourself in my class. That's not me. I'm going to say express yourself, but just do it in a respectful manner. If you think that I was unfair in how I handle a situation, you can come to class and talk to me in class and say, sir, I did not appreciate how you handled this matter. X, Y, Z. Not a problem, because your feelings. Your feelings. But all I'm going to say to you is that just be respectful. All right? So I'm going to say something to you. And I want you guys to try and understand where I'm coming from. So I would have met a few of you here in the past. All right? Some of you started this course, you stop, you start again, and you stop. And sometimes this may be your third or fourth or fifth iteration in doing this course. Some of you is the first time that you're doing the course. All right? Hear me out. I want you to find a partner in the class. It may mean that 3 of you together in our one group, but I don't want any one person to be alone. I want you to find a partner in class, and I want each person to hold the other person accountable. Each person is going to hold the other person accountable. So for example, Nesta and Daniel are working together. Nesta and Daniel can decide among them, between themselves, what will happen. Nesta and Daniel may say, okay, Saturday, we're going to do 8 o'clock to 10 o'clock, some calculus 2. When 8 o'clock come, Nesta call Daniel, Daniel call Nesta and say, what go on? The members who have to work some stuff. Now they told them they sit down and work, they book upon something and they understand them, say, the plan. This is one thing that we need to ask her for because we don't understand this together. You can drop me a message. If I'm available at that time, I can respond to you. If we're in a meeting, we can respond. If it's easy for me to make a WhatsApp call, we can do a group call with WhatsApp. We can say, well, go and say, no, man, you're right, but no, you're wrong, not it. Yeah. But I want each person to be accountable to somebody else. And I'm going to tell you something that happened. And I don't have a problem stopping my class to talk to you about it because I don't want to case like getting a calculus 2. I want to pass the course and move on. So I remember when I was studying on campus, I took a long break because I wasn't interested in my program anymore. So I took a long break. And then one day I said to myself, I said, but hold on there. Me not start nothing and finish it. I said, that's not me. He said, oh, if I don't like it anymore, I'm going to finish it because I started already. So I go back. And I went back. It was hard for me to go back because we just never want to see nobody, we just never want to do nothing. And I go back and sit at the back of the class and hear the lecturer talk and listen to the lecture and say, okay. But I mean, I was doing very well. I mean, I had collected a number of A's already in the program. And I said, well, no, say, no, so when I pull it down, I'm going to sit down at the back of the class, even though I was at the back of the class. I sit down and I look around the class and I saw one of my teachers from high school sitting in the class. And I said, okay. I said, well, student and teacher in the same class. I said, well, no things, man. And teacher turned and looked for me like me never remember her, but every time she looked for me, I strike on the board now because I'm not here in the mind. When class done, teacher said to me, hey boy, we're in the class. I said, no, so let's see, but and there. And she said, good, because we can't copy from you. I said, no. I said, you are the teacher. Says the student supposed to copy from you. She said, my brain, oh, your brain fresh. I said, all right, come to study. And I was accountable to her. She was accountable to me. Marking, she taught me in second form in high school. And both of us were accountable to each other. Yo, you do the assignment already? Not quite, I plan to sit up tonight to do it. I remember one course, we said, lady, you don't study? She said, don't study. You not start yet. She said, you don't study? Me say, yeah. She said, all right, tell me everything you know. I said, all right. And I started, and I was explaining to her the concepts. Now, that was good for me because we explained the concept. I wanted to make sure that I understood what I was explaining. And when I finished explaining the concepts to her, she said to me, yo, I don't study now because I understand everything you tell me. The long and short of that story is, when both of us went into the exam, both of us wrote the exam, both of us came out of the exam with an A, because I never hold back anything from her. The university have plenty of papers to give plenty A's, just like Excelsior. And I told her exactly what I knew. And the reason I did it because I wanted to see if I really understood the stuff. And she said, no, man, we have to do this again. And both of us worked together for the thesis. And we work, and we work. And guess what? The two of us graduated at the same time. We graduated from the university at the same time. She still teach, and we still teach. What's the point I'm making? When you hold somebody accountable, you're going to be pulling the person and say, yo, Nestor, you must say, no, go and write, get up and come and do some work. And Nestor will say, yo, and I said, no, go and write with you. And Nestor will do the same thing with Daniel. Daniel, yo, you sleep too much, man, come and do some work. Even a one question not about deliberate, it must work out. So come next class, they ask, who is working with who? People must hold you accountable to make sure that the course is not running away with you. You understand what I'm saying, guys?
Yes, sir.
Okay. Okay. So continuing. And especially, finally, people are working, and I don't expect you to stay at work up until 9 o'clock on a Friday evening. So you're in commute, so you're joining the class late. I should tell you this other part of the story. So we're moving to another class. I'm finishing work at 5 o'clock on a Friday. I don't know why I got a class that ended at 5 o'clock on a Friday. But class at UA started at 4 o'clock. So it's a 3-hour class. So you got 4 to 5, 5 to 6, 6 to 7. So the class is from 4 o'clock to 7 o'clock. I'm finishing class at 5 o'clock. I can't run out, just like how you can't run out from your work and shortchange my students. So I finish class at 5 o'clock. And to drive from down there, so for go up there, so sometimes a 45 minutes drive with the traffic. And for park, and walk, sometimes at 6 o'clock when I reach a class. I have 1 hour left. I have missed 2 hours of my class. And I will sit on in the class, and the same teacher lady will say, Miss Machino, because all them come to class and talk about this. I say, all right. You say, take notes? She said, she don't talk about nothing. I say, all right. And sit down. And she explained what I'm talking about. And I'm going to tell you, at the end of that semester, I don't know what my teacher friend got, but I know what grade I got. Because I know I was missing classes. So I had to put the extra word into it in order to get my A. So I'm saying to you, those of you who come in class late because they have to work, I understand. I'm not going to tell you to leave work early. I'll tell you to leave work immediately after work done. Not tarry because I have to come in to come to class. But I'm saying you have to put in the extra work so that you can meet the grade. It is possible. I'm not going to put in a semester. I don't want to face again a calculus too. Straight up. All right? All right, let's continue. So we put in our 0 into the function. So negative 120 divided by 1 is negative 120. All right? And then we can put all of this now into the formula. So work with me as I substitute this because I'm going to stop in another 3 minutes thereabout so that I can give you 7 o'clock to 7:10 to work on a question for me. I'm going to give you from 7 o'clock to about 7:10 to work on a question for me. So look at the formula. I want you to take a minute and look at the formula in pink. I'm not going to say anything until you look at the formula in pink, and then I'll come through with some stuff. Start now. All right, let's go. So now all the zeros, f of 0, f dash of 0, f double dash 0, f triple dash 0, f to the fourth dash d 0, f to the fifth 0, all of those I am going to be using. So I'm going to, and that's why I put them to the side. So I'm going to come back to them. So f of 0 is going to be 1. So that's what I'm going to write. This one right here. Then the next one is going to be f dash of 0 times x. F dash of 0 is -1. So it's going to be -1 times the x, here, -1x. F double dash is 2. So it's going to be 2 times x squared. Where am I? It's going to be 2 times x squared over 2 factorial. See here? It's f double dash is this times x squared over 2 factorial. Or if you want to say it, f double dash 2 over 2 factorial times x squared, same difference. See the term right here, so? And then f triple dash is -6. F triple dash is -6. So you're going to have -6 over 3 factorial. Where am I? Make this over 3 factorial times x cubed. F to the 4th is 24. So it's going to be 24 over 4 factorial, same 4 right as here, over 4 factorial times x to the 4th. Or -120 over 5 factorial times x to the 5th. See what you're saying? And then when I evaluate it now, this one is this. -1x is the same thing as -x. 2 divided by 2 factorial. Can I take out the calculators and work economically and multiply? 2 divided by 2, and then I press the factorial sign equal and tell me what you get.
Repeat 2 divided by 2.
2 divided by 2 factorial and tell me what you get.
So 1.
Very good. And 1 times x squared is x squared. So that's why I get the term here. 6 divided by 3 factorial is
1.
1. And 1 times x squared, -1 times x squared is going to be -x squared. Often you didn't get it?
It look like my forgot, girl. I go downstairs because my internet pick up. No.
Okay. Yeah, my one is in and out myself. All right. Hurry up and rejoin us. Or hurry up and change the location so you don't get disconnected. And then now, what is 24 divided by 4 factorial?
One.
1. And then that 1 times x to the 4 is x to the 4. Is x to the 4. So I'm going to have 1 x to the 4 plus x to the 4. And then -120 divided by 5 factorial equals
1 again.
very good. And that is going to be -1. Yes,
madam. You can go back up look for the top for me see the first derivative because I think I missed something. So a 1, oh, so I missed the 1. Okay, I guess. But I get a little confused because I think a -1 is starting. So I wonder where you get the 1 in the formula.
Okay.
But I no, my good.
Yeah. All right. So having gone through the review of that question that we did last week, let us do ready for the challenge?
Mhm.
Never back down from a challenge.
Example 2.
So I'm giving you example 2. It looks like example 1, but be careful because example 2 now has 2x, not right in the numerator. Yeah. But guess what? I promise you, the methodology is the same. The methodology will not change. You're finding the first derivative, you're setting the value of x to be 0. Then you find the second derivative, set the value of x to be equal to 0. Finding the third derivative, so forth and so on. This question asks us to go all the way up again, up to and including the term x to the 6th. Start from it, please. You talk to Shani, Otterly?
No, I know I never get to her, so. Can't try calling.
Rajay?
Yes, sir.
Good afternoon, evening.
Evening, sir. Say again.
I'm saying good evening, yo. You know, evening from me come across.
Tell them I'll give you the question, I'm so straightforward. Because they always come across and what do them and then when I'm going to exam them look fine to me.
Oh man. You see, what I'm doing to you know, I'm teaching the concept now. When you get the concept now, I put them in exam format, exam wording, and tell you how to look for the stuff. And then we're going to go to past papers. So you will see how they ask the question on the past paper, because I'll do the past paper questions. But for now, I'm just teaching you the concept. I just really want you to understand what it is that you're doing, and then we'll move into the exam format. Good evening, Ajay.
Yes, evening, sir.
Are you following what is happening, Ajay?
I came a bit later, so I kind of missed the coming off of the what we were doing last class. In between there, so I know kind of blurry.
What I was doing is just a review. All right, try attempting that question, and let me see how far you can go into the question, go up into the question.
All right.
Shane said she having some issue. She's going to be set up with her internet for tomorrow, but she and her data is on her phone. Data is done on her phone, so yeah.
I don't know problem. Cool.
Mhm. All right. So are we supposed to have a fraction and stuff?
Sometimes you will get a fraction answer. So it's not all the time you get an answer like what we got in the first one. So sometimes, yes, you get a fraction answer.
Okay. Yeah. X plus 3 times 0 is equal to, and then 1 times negative times 2. X plus 3.
Or are we okay?
Try, sir, try.
Finish.
Good job. You did the other side. 2 more minutes or so. How are we the rest of you?
Finishing the fourth derivative, sir.
All right, then. Good job. Tell me, did you get that?
Yes, sir.
Good job, Mr. What the rest of you, Daniel? Renee? Okay.
Yeah, I got it, sir.
No.
Natalie, where's it?
Yes, sir. But me not read so far. I did step away. Me not read so far. Me did just the second one and leave.
You go and work for me, please.
Okay.
Mhm.
I didn't get exactly that, sir. I made a little mistake with the denominator, but I understand the error I made.
All right, so you continue working, make the correction to that error and continue with the question coming, please, Rajay. The rest of you need to get that for the fourth and fifth derivatives.
Yes. Just a second. I'm gonna do the third.
No problem. Nestor, Daniel,
Yes, sir. I got that.
Yes, sir.
let me forget that for your series.
Okay.
Sir, you can go back up 1 second for me, please. To the start of the question. All right, okay, sir, thanks.
Sir, where you for the fifth? Okay.
That's what I got.
Yeah.
Daniel and Nestor. Projecting 1/2x+3. I want the pair of you to start those while I wait on the others to finish this one. Daniel, Nestor, start.
Okay, sir.
Right, 1/2x+3. Write it off for me, please, so that I can go back up, so that I can wait until the others finish those. And this one again, we're going up to x to the fifth. Now, when I go into the exam, they may not even answer all the way up to x to the fifth. But for practice purposes, I want to make sure that you're understanding your differentiation. Or remembering, I should say, differentiation, since we did it in a previous course. All right? So the pair of you, can I move and go back up to the previous question?
Yes, sir.
Thanks, Daniel. Nestor?
1 second. 1 second. One. Okay. Wait. Yeah. The next question. Thanks. -4. Good. Okay.
Oh, sorry, I was talking to you and I didn't recognize that I was still muted. I was asking you utterly if you got the answer for this one here.
I'm doing I'm putting the information in the calculator.
Okay, good job.
Yeah. Yes. That's the formula form that the full time. Divided by then 48 divided
Rajay, are you working? Rajay? Daniel, hope I reach the other question.
Sorry, that one you're different.
I'm finishing the fifth derivative, sir.
Good job, Daniel. This one is different because the denominator is not x plus 1.
Trying
The
to
denominator,
answer. Sorry, I'm again. I'm not sure. Stop.
go ahead.
Sir.
Oh, 8 o'clock. What say you?
How you work out there? Oh, 4 and 2. So we're not at the next question.
Oh, this is the next question, you know. No, this is not the other question. No.
That's what I say.
Oh,
Cause
sorry.
me get me there is second part where me get. Oh, okay.
Sorry, I thought I was projecting the second part.
Yes, over here. So how to work out the fraction? Cause me stuck right there. So me get
Alright,
the
you got-
negative 2 over.
You get the negative
Yeah.
2 over 9?
No, this how you work that? Yes, a negative 2 over 9. How you get that right?
All right, so maybe
We get that. We
Did
get
you get this for the derivative?
yes.
All
Yes.
right, good. So you may put it x equals 0 now. So it's 2 times 0 is 0. So it's going to be 0 plus 3 squares. 0 plus 3 is 3, and 3 squares is 9.
All right, good. Yes, sir. Get to this. That a bit different.
Sir, can you start? Because I still have to go leave.
We must start. Are you supposed to start a question?
Sorry, I'm finished.
You got these answers over here?
No, I'm not get the denominator part. I got the -2, 8, -24, 96, -480.
480.
My one wrong then. So I'm not know you get denominator part.
Let's go. Because this question has two sections, two parts. All right, so it says expand 1 over 2x plus 3 using Maclaurin series up to and including the term in x. So this is an example of a past paper question somebody asked. All right. The question says, hence or otherwise, to evaluate the integral of the first 3 terms of that function. We're not ready for that part yet. We're not ready for that part yet. We're just focusing on the first part. And the first part asks us to expand using Maclaurin series. Now, the first new Maclaurin that I need to do is to find f of 0. Anywhere in the function I see x, I put 0. 1 over 2 times 0 plus 3. 1 over 2 times 0 plus 3. Times 0 is 0. I'm going to have, and 0 plus 3 is 3. And
So
so I get 1 over 3.
3 for the first derivative right there.
I get 3.
The denominator.
I don't do the derivative yet, you know.
Or how you get 9 for the first derivative. How you work out the bottom part, sir?
Who's 0? Him do, I remember I used they got substitute 0 where x is now. So 2 0 2 times 0 is 0. So you go square
I
3.
completely forgot that.
Thanks, Otto.
Yeah.
Right. I'm saying it's going to be 1 over 2 times 0 plus 3. 2 times 0 is 0. Okay. Anybody see that?
Yes, sir.
Yes, sir.
Okay, now I'm going to differentiate. Differentiating the denominator times the differentiation of the numerator. The denominator 2x plus 3 times the differentiation of the numerator, which is 0, constant 0, minus the numerator minus 1 times the differentiation of the denominator. Now when I differentiate, as opposed to the first question, which was x plus 1, when I differentiate positive 3, I'm going to get I'm going to get 0. When I differentiate 2x, I'm going to get 2. So that's why I multiply by 2 here. Times 2. 0 times everything here is 0. Negative 1 times 2 is a negative 2. Over 8 plus 3 all squared. Similarly, anywhere in a function, you recognize this goes to 0, so it's going to have 3 squares. And 3 squares is going to be equal to 9, just 2 9s.
So, sir, basically, once we get the question, and depending on how the question is structured, we use the differentiation, we apply the derivative differentiation, and then work the question.
Everything the same.
Okay.
You find the differential, and you put 0 into the function. Yeah, everything the same.
Yeah. So you can get a question which you have to use the product rule or any one of the rules, the different rule, depending on how the question is structured.
I'll get one of the product rules. I'll get one of the change rules, the quotient rule. You can get one of the exponential function. You can get one of the logarithmic function.
Okay.
Any other questions?
But oh, we get it right, you know, it's just never mind. So I scroll down.
Sir, I'm not understanding how you get 16 over 27.
Did you get the differential correct?
Yes, sir.
You got this negative 48 over 2x plus 3 to the 4th.
Yes.
Or 2 times 0. 48 over 3 to the 4th power. And 3 to the 4th power is 3 times 3 is 9 times 3 is 27 times 3 is 81. Now, 3 is common. 3 into 40, 3 into 4 goes 1 time, and carry 1, 3 6 are 18, 3 2 6, 7 and 3 7 is 21. Put to the calculator, and you'll see come out as a 4. as negative 16 over 21 over 81 over 27, sorry, negative 16 over 27. So what I did was also reduce the fraction in its lowest term.
All right, sir.
Let's make this 600 pounds. This is
So you can scroll down.
And that's the end of that first part of the question.
So if we use we use the 48 384 negative 3840 for the answer, would it be wrong?
It would be wrong, and I'm not good to the examiner will just mark out the extra piece that you put in. If it is that you have all the steps before that, correct. Hosting, something like that, from hosting, wrapping up hosting. I won't get into this area. It's all what hosting, hosting.
So you ask a question, didn't hear.
I'm asking how I'm feeling. I won't need anything new tonight. Oh, I'm feeling two other topics.
Oh, better than last week. Much better.
I'm gonna end here. I'm gonna end here. What I want you to do, as I said before, I'm not gonna do the second part. I'm gonna end here.
So you
And then,
promise question.
huh?
Yeah, I think any promises say I give you something for do.
Yeah. So what I want to, so what I want, what I wanted to do, somebody asked a question if we can always get something like what we get in with the fraction. And I said no. So sometimes you get fraction, we have to use the quotient rule. Sometimes you have to use the product rule. Sometimes you have to use the exponential rule. Sometimes you have to use the logarithmic rule. See, I find one here that is the chain rule. But there's something tricky about this. This lets us expand that using Maclaren's inner theory of stuff. So we don't know where to stop, but while you can figure out where to stop in this one. I'm not interested in the last part yet, so don't worry about the last part. I'm not interested in the last part yet. Fair enough? Can you take on this question for me, please? You can just take down up to the first sentence. Start working on that one before you go to bed, please.
Using
Before
the
you go
chain.
yeah, you gave me the chain rule for this one. Start working. I will work and finish this one, and then when you finish, you go to bed, guys. Get it? Fair enough?
Okay, fair.
Check here. But everyone, get the work done up and I want to see it.
All right, sir.
Right.
May I write off a question? Don't end the class.
No, man, I won't. I'm just gonna mute.
Oh, which one you give us a while ago, sir? You move it. Oh, X1. Okay.
No, man, is teacher same one? But the first
Me just see
question.
it. Yeah.
Alright.
X 3 equals 2x. Sir? Using the current series.
Next calling me?
Yes, sir.
What's up?
Sir, the editors have something is up.
All right. Drop your emails in the talk. Oh, thanks for reminding me. Drop your emails in the WhatsApp group for me, please. Rajay, you too. Rajay, make sure you join the WhatsApp group. All of you drop your email. I think only 2 students are in there so far. So drop your emails in the WhatsApp group for me, please. And I will get you added tonight. Please and
Okay.
thanks. Thanks again. All right. If you have anything, can show me.
Anybody who is not, sorry for
Huh?
coming. Sir. No, it's saying anybody who is not on the group that I sent the link, you can just click on it.
Right.
All right, sir. Good night. Gonna try to work the question.
I'm not seeing the link.
Sorry, you can go back to the bottom of the last the question.
No problem. Send it back. Open. Yeah. All right. I'm gonna send it back. You seeing it now, Roger?
Yeah, I'll tell you, thanks.
Ah.
Sir.
Make sure you guys, make sure you do the work, Hey, Papa?
Yes, sir. I don't know. She was saying something, don't know. Oh, she left.
Oh, I had stepped away for a minute. Rajay, are you awake? Won't
Edit.
work.
All right. So I'm gonna try. Oh, my aunt edit us off. So that's to the activities, assessments. Everything expire. Sir, when you something about the lake, I thought tell me say everything expire. The permits? Sir? Sir, gone.
Just having a problem unmuting. You say what?
No, me the pan edit stuff, but it just tell me say me something expire. I guess because of the ones that we do already. May I see?
No, that's not pick it. Don't worry about that. That's not pick it.
Cool, no problem. All right, sir. Sir, good night. I'm try to see if I can work this and
All right, then cool. Take care. Rajay, how you stay? All right.